Hey everybody, the Open Air Guy here with another knowledge point. Today's knowledge point is on the solar spectrum and which rays actually reach the Earth's surface. The electromagnetic spectrum, or light spectrum, ranges from gamma rays at about a wavelength of 1 picometer to radio waves, which can have wavelengths of up to thousands of kilometers. Now, something important to understand is the sun emits the entire electromagnetic spectrum. Just not all of those rays reach the Earth's surface or even escape the surface of the sun. Gamma rays are short wavelength light rays, and that means they're high energy. High enough energy to do quite a bit of damage to human tissue. Fortunately though, they are produced in the center of the sun, and it's extremely unlikely for them to even reach the surface of the sun due to all of the matter and plasma they have to go through to get there. X-rays are longer wavelength rays than gamma rays, and so as a result are less energetic. They do, however, still do quite a bit of damage to human tissue in large amounts, and they are emitted from the sun's upper atmosphere. That means that the Earth is actually pelted with quite a bit of X-rays. The good news is, though, that the upper atmosphere of our Earth absorbs all of that radiation, so it never reaches the Earth's surface. Ultraviolet rays, the next up the spectrum, they are classified as UVC, UVB, and UVA rays. UVC rays are the shortest wavelength, therefore the highest energy, and UVA rays are the longest wavelength and the lowest energy. Ultraviolet C rays, like X-rays, are harmful to human tissue. Again, the Earth's atmosphere blocks all of that out. UVB rays, we'll talk a little more about those in next week's video in greater detail, but I will say that about 5% of all of the ultraviolet rays that reach the Earth's surface are ultraviolet B rays. The other 95% is ultraviolet A rays, and we'll talk about those next week as well. The next rays up the spectrum are the most well-known and typically what we call light. Visible light is the portion of the electromagnetic spectrum that is actually the greatest output of the sun by percentage. It's responsible for everyone being able to see what they're doing and for color. Infrared light is next. It is emitted by the sun in greater amounts than ultraviolet, but less than visible light. It is responsible for the heat that we feel from the sun. In fact, it is responsible for the heat that we feel radiated from any object that is above 5 degrees Kelvin. Infrared radiation is harmless as long as it's not in too great amounts, which can cause burns. The next rays we come to are microwaves. They are emitted by the surface of the sun, as are ultraviolet, visible, and infrared rays, and they pass pretty much straight through the atmosphere. Now, microwaves can be damaging to human body in too great of amounts, but not directly. What happens is microwaves are strongly absorbed by water. So if too much radiation is received, the water in our body can heat up and even boil with excessive exposure. This can cause a lot of problems in the body. However, the amount of microwave radiation from the sun is small enough that it doesn't cause any health issues. Radio waves are the last electromagnetic waves on the spectrum and are greatly reflected by the atmosphere. That is the reason why ham radio signals can be sent and received from opposite ends of the Earth. There is a portion, however, that is refracted by the atmosphere. The amount that is refracted, as well as the depth of penetration into the atmosphere, is dependent on the specific wavelength of the waves. Radio waves are harmless to human beings as the wavelengths are too large to interact with the body. Okay, so I hope you enjoyed that video. If you did, remember to subscribe to my channel and hit that little bell to be notified of new content. Next week's knowledge point will be on ultraviolet rays and how they're affected by the atmosphere, weather, and even elevation, and their effects on the body. For now, this is the Open Air Guy signing off, and I'll see you next time.